Hi, we finished the software project planning. We discussed in the past 2 weeks project scheduling and project estimation. So we're done with project planning, and starting from this week, we are working on the topic in the software configuration management and the defect management, continuous integration. That's the other part of project management. Okay, so the first topic is software configuration management and SCM. I showed you these slides before and why we need software configuration management, and I show you the software process. Let me show you here. Yeah, I show you these slides. This picture, the software, I mean the different releases, is not a straight line from the release 1 to release 4. It's not this straightforward. Most of the software is actually having this tree structure from the initial release, the starting point, and then different releases focusing on different aspect of the software. And you may have, for the different customer, you have a different configuration as well. And each dot here is just, well, it is not a dot. And when you zoom in the dot, you will see that for each release, or for each version, there's thousands or even hundreds of documents associated with one release, the source code, the data, and even compiling and building tools and so on. So each dot, if you look in the detail, there's a lot of information inside. So this is only for one product. It may go through this path. If you have more than one stuff, if you have more than one product, and each product will take this tree structure, and some branches they may merge and become a new product, become the starting point of a new product, and that's also possible. So eventually, for big company, it's not just a tree structure; it can be a forest. Then thinking about for each dot here, and each dot here is a release, and between the release is a build. And each build contains the same amount of information. Then you can see this is actually a very complicated structure, and of course, we need the tools and we need a team to manage this data. So this we call the project repository is the most important asset for any company, and they don't want to mess up with this. And they have a dedicated team manage all the releases and associated document, and they have a strict process to make change. And they have like a version control once it reach to a certain point, and to release the product, and they have a review, they have an audit team, they have a lot of work to do before they release the product. So you'll see that it's a very serious matter, and the core concept here is the requirement, is the software configuration management. It's all about the change. It's all about the change. So we know the change, software change, starting from the initial release, and eventually become tree structure, and then the future become a forest structure. And so you will see that the software grows. The growing process is a change process. Software change are inevitable. You cannot expect the software to remain the same. That's impossible. So prepare for it. Configuration management is all about the change control, change in different level, change of individual item. Let me see. Change in the individual item need to go through change, and the versions from one version to another. So there's a version control, and then for the individual build, individual document, they have a change control. So it's all about manage this huge amount of data. Then let's see some key definition in SCM. The most fundamental one is called software configuration item. so definition is an approved unit of software code, document, or piece of hardware that's designed for configuration management and treated as a distinct entity in the SCM process. So let's go back to this picture. SCM item is when you zoom in each release or each build, the individual item here is called SCM. Requirement document, design document, source code, data, test case, tools, manual, everything included in here is called individual one. We call it SCI. SCI version. SCI version. So the approved state of an SCI at any given point of time during the development or maintenance process. So the SCI, you'll see that the different dot have the same amount of document, a requirement document, and so on. So you will see that the requirement document goes through different versions. Goes through different versions. So this is called configuration item version. And some document like the source code, we know the source code is big. The source code is big. Source code you can consider as consists of the code, and you have classes, and you have some data is also part of the source code. So for some source code, for example, like we have a.cpp in the release 2 and the release 3.1. I also have a.cpp. So these two a.cpp, they can be the same. Yeah, they can be the same, or they can be different. It's all depend on when they have different requirement, and then when the requirement changes, and then the engineer analyze the software and find out what code needed to be changed. So in other words, some code will be changed and some code remains the same. So it is very common that even they have in two different releases, and some code remain the same and some code is different. Okay. So that's called configuration item versions in different software version, and some code can be the same and some can be different. Baseline. Baseline, according to the IEEE definition, is a specification or product that has been formally reviewed and agreed upon, that thereafter serve as the basis for further development, and that can be changed only through a formal change control process. So you will see that the software will go through a very long journey from one version to another. So in between these two releases, you have different build. Okay. But once you further go into between different build, you have different, you are define like the milestone. You define milestone. So each baseline, a baseline is baseline and the milestone. The differences of baseline and the milestone is a baseline is after review. You review everything you have done at this point, then that milestone become a baseline. Remember last week we working on this project planning, and for each category activity. By the end of them, there is a milestone. That's a milestone, but not all milestone is baseline. Not all milestone is baseline, but all baselines are milestone. But not all milestone is baseline. The baseline means you have to do the formal review and agree upon. and everyone agree, and then further serve as a basis for the future development. Then once you do the review, then that milestone become a baseline. But all baseline is a milestone. Okay. And then let's see how to form a baseline. So here we have project database. And then we check out. We call it the extract the document out from the database to do some work and modify the items, and then before you check back in, we go through the technical review and then make sure everything is correct and approved by a committee, and then store in the project database. Then this will form a baseline. Okay, now let's go into a very important concept: finding the configuration items. So large projects typically contain thousands of entities, file, document, data, and even some intermediate, the memo you communicate with customers. So there's a lot of things. So what we should put into the configuration management? Should we put everything we produce in the process into the configuration management? That would be too much. So there will be to finding the right item and put them into the configuration management at the right time. We have to answer two questions. The first is what. What are item to be chosen, and the second one is when. When you start to place entity under configuration control, because once you put it under control, it will require the resources and the configuration management will go through the process, and then the change. Making change is not trivial. You cannot do it well. So when it goes through the process, then it require the resources and the management to do that. So the timing is also important. The first one is what, and the second one is when. There's a conflict for any project manager. If you start with the CI tool earlier, introduce too much bureaucracy, because there's something unnecessary still will go through this review process. That's a waste of time. And starting too late, introduce chaos. So we find the right timing, and so when a document is produced, and then you may think that we put immediately into the configuration control. That's not true. So when a document is produced, and then later, sometime in the future, when this intercollaboration is necessary, and you expect a lot of changes, is going to be on this document, and this change must under control. Then you put into the configuration management. So it's not always when you create a document, then you throw in the configuration management immediately. That's not the case. So you have to, as a configuration management manager, you have to think of two issues. What to choose from a large selection, and when to put under control. So these are the common SCI configuration items, like a design document, the source code, and the data file, the data including the test cases, test script, parameters, code, and so on, and code for the test cases, and then tools, development tools. So this the compiler, debugger, application generator, case tools. So any tools you will use, we'll also put into the control. The reason is, if you ever write code using the Microsoft Visual Studio, you will see that Visual Studio goes through different versions, and the new version may not compile the old code. So in order for the old code to be compiled and debug, it's better for you to archive the old code, the compiler as well, so that you can easily pull out the whole environment, throughout the whole environment. It's not just the code, the document, including the environment that is code being compiled, so that you can, working on, you can regenerate this working environment and working on the code. And some other items, you think is necessary to manage the change. And then just compare the two versions. As I mentioned, when you have a software may go through the different versions, but some items may remains the same. For example, like the requirement document is, for the two version may be the same, and some other document is different. 3, 4, 6, 7, and some version, some code. I mean, between two versions may already go through uh, 3 versions as well, from version 3 to 5, and you'll see, you will imagine the version 4 in between, and then this version 4 may apply to like the version 6.5 or something. This you will see that the code can have dramatic change. Let's see the ACM process task. And what task we should do. The first one is identification. We already mentioned that what should be put and when to put them under control is the first one is identification. Then we have two controls. One is the version, is control the changes before and after the release, before we release to the customer. And then here we need to make sure everything we try to release is on track and is correct. So we have a version control, and then this change control happen more frequent. So this one is authorized to approve and prioritize changes. So you think about between two versions, how many changes you're going to do, how many code design will be changes. So we need a process we need a process to authorize and prioritize the changes, and then make the change and auditing the change. So here we have a two level of control. One is the version, is the software as a whole, and then the change control targeting individual SCI. And then we have a configuration auditing. Since these two controls involve so many processes and so many people involved, then we have auditing, make sure the changes are made properly, because this due time is, the deadline is near, and then people may take the shortcut and bypass some important step that must be conducted. However, people may just bypass to meet the deadline. So the auditing will, become a balance. Yeah, if everybody do that way, that would be dangerous for the software. But sometimes you cannot be that strict, because the deadline from the management point of view, from engineer point of view, is always the most important goal. So I want you. So this configuration auditing will make the balance between meeting the deadline and also at the same time not everybody, not follow the rule. So this rule enforcement and meeting the deadline. This configuration auditing will try to balance this. You cannot just be too strict or too loose. And of course, in order to do that, we need a reporting to keep everybody on the same page. So you will also have a reporting involved. So everything targeting these SCI items, these thousands of entities, and then we identify them, and then put them under control. And then initially it's just a change control is for the individual one, and then when we make enough change, and when we approach to the point to release the software, then we have a version control, and then of course we have two supporting activities is auditing, and the reporting is to keep everybody on the same page. Okay, so we have these layers we call HCM layers. Yeah. Version control, combine the procedure and tools to manage different versions of the software. And the version control system will have this major capability. Of course, first project repository. We put them in the repository, and has a version management capability that store all versions, so that you can create a version from past version. So that you store all the versions that you can easily combine items, combine items from different versions from the repository and form a new one. And it's a make facility that enables software engineer to collect all relevant configuration object and construct a specific version of software. And also there's a issue tracking capability. So these are included in the version control. So this version control is done before and after release. So that's close to the release time. We have this version control. In our daily life, we're more involved in this change control process, because the change control process is aiming targeting individual items. So as an engineer, and you will go through this process, and what I show you the process here is a very complete process, and you may think this one is a kind of bureaucracy, but in your working environment you may bypass some steps, but please keep in mind that this so the process I provided here is more like a template. Yeah, you can customize, you can skip some step, and you can use a different team to or the same person play multiple role in here, but you still follow the template. Yeah, you will still follow the template. The first step is change request. So the change request can come from many different sources, can come from customer ask for the feature improvement, can come from the testing team when test the product and find some issue and ask you to make change to the software to fix the issue. So the change request can come from anywhere, or even from the manager, yeah, from or from your peer, when you do the integration and find out, his code and your code is not compatible, and then your peer may also ask you to make change to your software. So that's the change request can come from different sources. And anyhow, the change request is submitted and it's being evaluated to assess its technical merit and the impact on the other configuration object and budget. So your change request is submitted and must be evaluated by the team. And then, by someone. The change report. So after evaluation, this a report is generated containing the result of this evaluation. And then the change control authority, CCA, make the final decision on the status and the priority of the change based on the change report. So think about a day, there's so many change requests. And then we must have a team to decide decide the priority of the change. You cannot use the first come first serve. That would be a chaos. There must be some priority here. So the CCA's role is to make priority of the change request. And then once the change request is approved and put in the queue, and then engineering change order is generated for each change approved, and the ECO describes the change, list the constraint and the criteria for review and auditing. So here some more information about it. It's not just the value or merit, and here describe the constraint, the criteria, and the review, so that the auditor can follow up. And then the object to be changed is check out from the project database, and then the next is then the engineer can working on the checkout object and make a change to the code and add into the code and so on. And then The modified object, think about the modified code, is subject to appropriate SQA review and testing procedures. So you cannot just check back in, and you need to do some process testing, review, and SQA in order for you to check back in. After done this testing and the review, then this new code we call the modified object is then checked in to the project database. And the version control, if it is near the release, and the version control are used to create the next version of the software can be. And then synchronization control is used to ensure that parallel change made by different person do not override each other. So this is also very important in a large project. Think about you have hundreds of people working in a team, and it's very likely like for a very large class, the code, and you assign to different people working on different methods, for example. And then so that the same code is going in parallel, and then you want to make sure nobody override each other. And today in this week lab, and we will practice this. Yeah, we will simulate the situation that a manager assign a large class in Java to different engineer, and then they create a branch and working on in parallel, and later on you merge them, become a final code. So we are simulate this process today. Okay, so this synchronization control is used to ensure there's no overwriting. So here I use a chart to describe the change process. And need for change recognize, change request, and then evaluate the change, and the change report generated, and the CCA to decide. There's a two decision. One, the change request is denied, so the user is informed. So or in most of case, the request is approved, and the request is prioritized and put in a queue, and then assign people working on the related item, and check out the item, make change, and review the change. And once the review, we establish a new baseline for testing and SQA. Then eventually we check in and promote SCI for inclusion in the next release. So this is a version control now. So this one we have the multiple items need to be included in the next release, and rebuild the version, and then review and order change, and you include all change in the release. So basically, this is the this change request, change control procedure, including the individual change and all the way to the release of the new version of the software. Okay, let's see the auditing. As I mentioned, that auditing is like the counter is like a counter action of everything here, is to make sure you follow the procedure. Make sure you follow the procedure. As I mentioned before, sometimes it cannot be too strict. Yeah, too strict. So I have to be, balance the deadline and the procedure. And the report. The last one is the report. We'll document what happened, who did it, and when did it happen, and what will be affected by the change. So this document generally will answer these four questions. Okay, so we quickly go through the concept of configuration management. So I think the concept is not that difficult to understand. So you have to get out from the mentality that you are writing the code on yourself, all by yourself. It's not like a hello world or the code you write in your data structure. You are the only one who working on it, or even you have a group project, the group can't be that big, can be like 100 of people working together. So you never working. In a school environment, you don't have chance to working on like in the industry environment. So this configuration management is more like in the industry level mentality. So you have to put your feet in their shoes. Yeah, in their shoes. Think about this software is not just a code can contain so many information and this so many documents, and then they're in different versions, and you are only one person. You're only one of them working on a very small part of the software, and at the same time there's hundreds, even thousands of people working on at the same time. So in this environment, we need the tools help us doing that. And then, so there's so many tools that serve this purpose. And what we introduced today is the Git. It's kind of new. Yeah, it's kind of well, it hasn't been it's been around for not that long. I know the CVS has been around for a very long time, and the ClearCase by the rational now is a part of IBM. Is a commercial tool, and this tool has been around for more than 20 years. So Git compared with them is relatively new. We will talk about the Git, and in the lab you will practice Git. So here, let's see first the CVS. I will skip this part because the CVS still people still use it, but not as much as Git. So we'll go directly to the Git. So Git is a distributed version control system. Okay, so what that mean? Okay. So the CVS is called concurrent version control. So you have a central repository. We call it central repository. Yeah, we call it R. Central repository. And then you have a different you have a different user. Okay. You have a user 1. You have a user 2. So for the user to connect with the repository, there's a number of ways to connect it. And you can use the FTP. You can sometimes the repository, you can create your own repository, and then this repository is in your local machine. So this or you can use other network protocol to connect with the repository. There's many ways for you to connect to the repository. However, you have only one repository. This repository contains the project file. Then the user check in and check out, check in and check out. So this is how we call it centralized. You have a centralized one repository. So this is a traditional way of doing this version control. Then what is distributed version control? So this implies, distributed version control is you still have a central repository. You still have your central repository. However, the user can have your local repository. You can copy the entire project into your local, and then you're working in here, and but still your user 1, user 2, three. Okay. So this means this you have distributed repository, so that the user can. The reason behind that your local machine can copy the entire repository. The reason behind is your local machine become very powerful. Nowadays, we know your laptop can have 1 terabyte. You have 1 terabyte, 1.5 terabyte. You have the capability to store a lot of information, and also your local machine become very powerful. In the past, like 20 years ago, 10 years ago, your local machine, the laptop is not that powerful, so that you only check out what is required in your local machine. But nowadays, you can take the whole repository to your local and do the compiling and building in here, and then make sure this is working. Then you synchronize with the central repository. So now you have the ability to do that. So Git is working on this environment. Is working in this environment. Okay. So these are the online materials. Go to git scm.com, the GitHub. So the GitHub is the place. And so any of you used the GitHub before? I guess quite a lot of you should have experience on the GitHub. So GitHub is very much like this repository. So the whole it's like a central repository for the whole group, and then for the individual user can clone. They call it clone. Can grab the whole repository into your local machine and working locally. So this GitHub is like the central hub for the entire team. Okay, so GitHub now is a so if you go to GitHub, you do the search, you'll see there's so many code. Yeah, there's so many projects you can explore, and GitHub is my favorite website. Yeah, and I go there and search some new development of the various tools. So the Git itself is working locally. Git is working locally. So to manage your local repository, and also at the same time you can synchronize with the central repository. So Git mostly working on your local machine. Okay, let's look at the Git command. So I have a slides here. You can go through all by yourself, and to better understand the command, let's look at the lab document. Okay, so this is the lab document I post on the Canvas. You have by the end of the day to finish the lab. And then this is the lab task. The lab has 4 tasks. I want to show you the setting of the lab, and let you know the scenario behind the lab. So let's see here. You have you're working on different branches. You have a master branch, you have a Tom branch, and a Bob branch, and then you merge this Tom and Bob into the master. So what's the scenario we are talking about here? Let's hear. So in this lab, you are playing different role. The first role you are playing is the manager. Your manager role, and you have a developer role. Okay, you are playing the dual role in this lab. So as a manager, you're working on the master branch and create a source code and let different developer working on different part of the code. So in the task 1 is the master branch, and you as a manager is working on the master branch and then create the file called doc.java. You create this code, the template, and then you are working on one method called fly method. You are working on this, and then you assign this source code to Tom and ask Tom to working on a method called swing method. And at the same time, you assign this doc to Bob. Then you ask Bob to working on eat method, and you are working on fly. So this is the setting of this lab. You first, as a manager, you create this repository, and you create this doc.java, and then you're working on the fly method, and then you give the source code to Tom and ask Tom to working on a swing, and ask Bob to working on eat method. After both of them finish, then they merge their work back to master, so that you have a complete code of .java. So that's the task we are practice in this lab. Now let's go back to this lab document. We see the task 1 is under master branch. I will go through each step and show you the result. So you first create a folder like a labs 3 and my app, and this is what I did, and I have this my app. So far this folder is empty. And if you want to apply this Git on this folder, what you can do, of course, you need to first install the Git software, and then you can use it. You right click on the my app, and here you choose the Git bash here. Okay, so you will go here. So so now Git is already applied on this folder. If this is the first time you use Git, you want to do some configuration. The task 1B is to ask you to create a contact, so that when you interact with other people, they know who you are. You need to configure your name and your user email. So let's put in here git config global user.name. You can say my name is Tommy. Okay, now I create my name. I create my email. Okay, I create my email. Now this is a way you can check your name and email if they are created successfully. You go to git still config list. Then you'll see that username. I just have my username and my password. I'm sorry, my username and my email, and I know this is correct. Okay, now the first is to create your contact. The next task C, is by using git initial to create a repository. So far, if I go to my app, you can see this folder is empty. There's nothing in there. Next, I need to create a repository. So how to do that? Git init. I create. Because as soon as you run this command, you will see in here my app folder has a .git hidden folder being created. So in order to see this, and you must let your browser to view the hidden file, so that you can see this file is created. Then you know your repository is created successfully. Next is to the 1D is to create a new file. So what you're doing here is you are now in the master branch. You want to create a new file, because so far your repository is empty. There's nothing in there. You need to create this file. So in order to do that, there's a number of ways to do that, and one way is use the touch command, or you can just go here. You can just create a new file. I mean, in Windows you can create a new file. So let's use this way, touch doc.java. Okay, I could see that this file is being created. Okay, now the file is created. That doesn't mean this file is in repository. The file is still not in repository. So next is to use the git add command. to add a file to staging phase. So what do you mean that? Okay, let's go back to here. In Git, file has 3 status. The first one is new, is a new file. Okay. So this is when I run the touch. Doc Java, then I create this new file. And then in order to commit the file into the repository, it has a intermediate status called staging. Okay. So after that, then you can go to committed. Has these 3 status. So this is using the git add command, and this is git commit command. So the staging, so new, the file is in local, and in the staging status, the file is still in local. But once you run the committed, and this file is in repository, Okay. So the file will go through these 3 status. So in order for the new file get into the repository, you needed to run this add, and then run commit. Okay, so let's go here. I first git add. If you want to add everything there, you can just use a dot or use a. So to make it simple, I always use a dot. Git add a dot, and then this will add my file. Then if you go to the git status, I check the file. I have this file, and it to be committed. Next, I git commit. So to commit, you need to give a message, and this message is very important. So this will keep track of what you are doing, and so every commit has a message. Then we can go back to check what's going on down the road. So here I can just give an initial commit. Okay, so now the file, if I go here, git status, then you'll see that it's on branch master, nothing to commit. So this shows that this doc.java is already in the repository. So here we are down to A, B, C, D, E, F. Now the G is to add a fly method in the doc.java. So in here, I want to use the atom to do the editing. I know there's a lot of editor you can use. If you're using the Java, you can use Eclipse. You can use NetBeans. So there's a bunch of tools you can use to edit the Java code. But in here, I want to use the atom. The atom. Okay, let's open the atom. No. Okay, I open the atom, and then in order for the atom, so yeah, I will show you the advantage of atom later. So here just install the atom and then try to use the atom. So in here you can open folder. Okay, you open folder, you go to the my app folder. Select this folder, then you'll see this folder is here, and then you see the doc file, the doc.java is here. Okay, and let me close this. Okay, let's go to here. So yeah, let's organize them, make them in one screen. Okay. Okay, now I'm in the 1G to add the fly method here. So first I create this class called dark. Okay, then I add a fly method, and this fly method you can check the page, the last page of this lab document. I have the source code. So the purpose here is not practice the source code, is to let you working on the Git. So the code itself is quite simple. Print line. Just a dog can fly. Okay, so this is the code. Then you need to save the file. Save the file. You can click on save or just Control S. So here before I save the file, if I go to the Git status, you see there's nothing changed. As soon as I save the file, and then I run this Git status, it says that I changed the code. Yeah, this modified. This doc.java has been changed. Now the file is, you can treat it as a new file. It's not a so the file is in the new status. Even if modified, we still consider the new. It's not staging yet. It's not committed yet. Okay. And then here in the 1G, I want you to run the git diff to view the differences. So if I run the git diff, you will see, okay, this is a command line, and it show you the old file and the new file and what differences of it. You can see that this interface is not handy, it's not user friendly, especially when your code become very complicated. You have so many lines, then this is not the friendly way to view the differences. Then we have a much better way to do that. So here I want you to use the Win merge. So I provide the Win merge, the portable Win merge. You can download and follow this instruction to use the Win merge. So let me show you the differences of the Win merge to the diff. I run the command git diff tool. I'm going to use Win merge. I say yes, I want to use the Win merge. Okay, so you can see here this is a Win merge. So Win merge is a window interface to compile on the left hand side. This is the old file. Of course, there's nothing in there, and this is a new file. And then if the file, so the highlight means this one is is different from the previous one. So from here you can see that this interface is much more friendly. You can compile the old one and the new one, especially when the source code is complicated, very long, and there's some, then you make changes, and this interface will be much better than this command line. So I want to use the Win merge. Of course, this one is so the Win merge here is optional, but it is a very handy tool. I want you to practice. So in order to configure the Win merge, you can follow my instruction here. You download the Win merge and from Canvas, and then unzip it. And in my machine, I unzip to this folder. And then I added this git config file that located where you install the git. And in my machine, my git is installed in here. So I go to this folder. Let me show you this folder. I go to my C drive, I go to the program file, and I go to the Git. I go to the etc, and then yeah, you see here there's a git config file. Okay, so you need to edit this file. I added this file, so you can copy and paste. You can copy and paste this part in my Word, in my lab document, into the end of you can just append to the end of this git config file. So in here, just copy and paste in here. And of course, if you are unzip the vmerge into a different folder, and then you need to change the folder here. Okay, so once you add this 1, 2, 3, 4, add these 4 lines here, and then you save this file, then your Git is ready to use the vmerge tool. So here shows you that in the in 1G, when you show, so anytime when you make a change to the code, you want to see the difference of your code, you can either run as a git diff, and I mean, for complicated code, it's better to use the vmerge. So this will give you a better interface to see the differences of the old code and the new code. Okay, let's go back here. So now I'm done with the master branch, and as a manager, I created the fly method. The next, the manager is going to assign the swim method is create a branch called Tom and ask Tom to working on this swim method. So let's do here. Let's go back here. The task 2 is end branch. Is under Tom branch. In order to create Tom branch, you need to git branch Tom. This is create a branch, and a git checkout Tom. So the checkout is to switch to the Tom. So this is this command. Okay, this command. Okay, now you see here I'm in the Tom branch. Before I do that, you can see that there's a master showing that I'm in the master branch, and now I'm in the Tom branch. And here in the Atom, since Atom is designed for the Git, is a handy tool. It can also show you a lot of information. You can see here is I'm in the Tom branch. So here you can see that there's a Tom branch, the master branch. So there's a number of ways it can show you where you are, and this Atom is configured to work in line with this Git. So whatever change in here, it will also reflected in the Atom. So that's why I'm saying this Atom is a very handy tool for the Git. Okay, now you are in the now you are in a Tom branch. So Tom is responsible for the swim method. So in the Atom, you create a method called swim. You can say the system dot print that can swim. Okay, the same, you need to save the file. You save the file, then you save the file, and then you repeat E and F is to add and then commit. So what you do is to git add and the git commit with a message. With a message, you can say that Tom add a swim method. Okay, so now from the Atom, you can see that in the Tom branch you have this swim method. if you go back to see this master branch, this why there's nothing in there? Yeah, the master branch doesn't have it. Oh, I see. Yeah, because the first one I add this fly method, I didn't commit, so master branch is still empty. I see. This Tom's branch has a fly and a swim, but this master branch has nothing in there because I didn't commit. Okay, yeah. In here you see that I add a fly, but I didn't but I didn't commit. Okay, let me go back. Check out. Check out master. Git status. Yeah, there's nothing to commit. Okay, let me work on this one. Okay. Public class doc. I should commit it. Print line. The duck can fly. Yeah, I'm supposed to do that. I'm supposed in here needed to. So I can go to the command line to add and commit, and I can also go here. I can just say that master add a fly method. I can just commit in here. First a stage all, and then commit to master. Okay, so there's two ways you can do that. You can either go here, commit add, commit git, I mean git add and git commit, or you can just go to the git, go to the atom and do that in here. So I mean this, so you'll see that this atom is designed for git and is very handy. Okay, so now my master have this, and if I go to the Tom is different. Tom has a swing, and master. The master has a fly method. Okay. So I finished the Tom, and then I go to the task 3 and on the Bob branch. And go to first I add a branch called Bob. And then I check out, I switch to Bob. Now I'm in the Bob. Okay, now I'm in the Bob. Now I add sorry, not in here. Public. I add a eat method. I say this a dog can eat. Okay, now I save it, and I go here. I add a commit message. Bob add an eat method. I stage all. I commit Bob. Okay. So this is identical to I go to the git command. I have a git add, and then I git commit. So I mean these two commands is identical. I click on here, staging all. I give a method here. Okay, so here I have a Bob is on. Bob has a eat, and then if you go to the Tom, you see Tom has a fly and a swim, and the master has only a fly method. Okay, so now master finished the fly method, and then Tom add the swim, and the Bob add the eat. Now I need to merge Tom to master, and the eat to fly. And the Bob to master. I need to merge these two. Okay, now we are in the task 4. I first uh, merge Tom, because now if I do the merge, I may have an issue, because this master is the master one I create, is the Tom branch is empty, but now now the master branch has something. So let's see what happened. Let's see what happened. I git merge Tom. I give a message. I say this. Now I merge Tom's work. Yeah, you can see. Yeah, I can tell that there's a conflict. Yeah, there's a conflict. Then if there's a conflict, there's a way that shows that they have a conflict in here. You see that public is right, but this public K, the Tom's one, is not right. Yeah, this has a K here. So what I do is resolve as ours, then theirs. Yeah. Okay, I use this option. Okay, so from here, see that, and here also there's right here as ours. Now I see that this public. This typing is wrong. I delete it. So here I can manually make change, because this so when there's a conflict and the Git cannot figure out which one is right, it will pump up this message, ask you after you to intervene, to jump in to make a judgment. Okay. Now I save it. I fix the conflict. I save it, and then I go back. It says merging. Git status. Okay, now you have a new one. Git add and git commit. I can say this fix conflict between Tom and master. Okay, now I merged. Okay, now I fixed the problem and do the merge. Next is to merge. Bob. Git merge Bob with a message that says merge Bob's work. Okay, yeah, this one has no conflict. Yeah, because they don't see any conflict. So this one, this shows that the Git can do the merge automatically. So in the case one, when I try to merge Tom, I face an issue because there's a conflict, but now there's no conflict here. Okay. And then the last task is to give you the overall picture of what's going on in here. So I run this command. It's called git k. So this shows that so this is a picture I want you to create a screenshot. Yeah, so I can see what's going on in here. So this give the path we are going on. So if, first we have a initial uh, uh, initial commit, and then I create a Tom branch and the Bob branch, and then the Tom merge and the Bob merge, and then I have the merged. I mean the final code of a master. So I want you to show me the screenshot of this, and then I know what you go through. Okay. I think that's it. For the lab. So the lab has 4 tasks, and in the appendix, I give you all the git command you may use and you will use in this lab. And in the appendix 2, I give you the instruction how to config and use the Win merge. And appendix 3, I have the example source code. And also I give you this a screenshot. Yeah, that I want to submit along with your lab assignment. Okay, the deliverable, I see that first is a Word document, should a screenshot of git k, and also I want you to include your folder, your my app folder. Yeah. Okay, this yeah, I think that's it for today. And the TA will see you in the lab.